So our objective is to create a LTE network. Okay, that's a combination of it's a heterogeneous network basically with 3G base stations as well as Wi-Fi networks. Okay, so first we are going to set up a network, say for example with 30 nodes. Okay, now the major objective of 4G network is to get the nodes connected with the internet, right? We need to give an internet node which is node number 1 by default, message length say 100. So nodes are going to exchange HTTP packets with the internet 10 times, round means number of times. Let's say that the SNR in the network is very low, that is the network is quite noisy out there, right? So let's give an SNR value about -20. Let us say that number of nodes in the network which are going to transmit to internet is like 2, 4, 9, 11. You can change the number of source nodes. Okay, let's generate a network. When you generate a network, you can see green color mark over here, triangular mark, node number 15, 30, 25. So what we have done is we have given all the nodes with modulus 5 equal to 0 as the base station nodes. Okay, so node number 5 is a base station, node number 10 is a base station. So yeah, so what we are going to do is propose routing with neural network. Now you can see from node number 2 to 29 it's going to transmit, and every step of transmission it's going to keep on checking the noise. Okay, the neural network is going to keep on classifying the noise, and in case the see whenever there is a red node it's going to keep classifying that there is a very high noise or something. Okay, under that situation there will be a route change. Okay, there will be a handoff, immediate handoff. So the objective is to keep the noise low and medium. So once the noise is medium, the path will be retained. Okay, data will be transmitted through the same path, and once the noise becomes very high, the path is going to be changed, the route is going to be changed automatically. Okay, so till medium noise is there, till the noise is medium, it's going to be as it is. Okay, once the noise is high, the route is going to be changed. At the end it's going to give us what is the average energy consumption, average delay, average BER, and average energy left. Okay, these are the four parameters. We have to prove that proposed system is better than the present system with the context of these four parameters, right? Now we have got certain bit error rate over here, right? We have done a set of data transmission, right? So what we are going to do is we are going to train the neural network with current set of data transmission. Okay, so we are going to train the neural network with current set of data transmission. When you see the neural network, there are four output layers. What are those four output layers? The four output layers are low, okay, medium, high, very high. These are the noise factors. Okay, you can see there are two input factors. What are those input? We have considered delay and energy as the parameter by means of which it is going to be transmitted. So delay is converted into bandwidth, and based on average bandwidth remaining and average energy remaining, we are predicting the error. Based on what we are predicting the error, we have a parameter called bit error rate, right? So as the data transmission has happened, the node will show the bit error rate. So if the bit error rate is 0 to 1, then we'll say it is low error. 1 to 2, medium error. 2 to 5, high error. 5 to anything above 10 is very high error, right? So once the neural network is trained, again for the next cycle neural network will be automatically able to utilize this data. For example, now let us generate the network once more. Okay, this case we are going to give SNR bit higher. So if the SNR is bit higher, now you should not click new simulation because statistics are reset. Now I want to plot a graph, okay, which should be smart. So propose routing with neural net and keep on starting the data transmission. Now whenever there will be a very high noise, the system would try to just shift the path, because over here a lot of data is getting transmitted. Okay, so it's going to, now you can clearly see that the energy is not down. Okay, node is having sufficient energy, but because of low bandwidth also it is showing very high noise. Okay, then it gets shifted to high noise. Now again, now the energy is also down. The noise, that is the simulation engine that says, neural network says that it's a very high noise. So now you see bit error rate, there hasn't been any bit error rate. Okay, even if even though there was extreme noise, average delay is about 19, average BER is about this one. So how you should interpret? Now what we are varying, basically we are varying the number of rounds, so you should keep on varying the number of rounds as the number of rounds varies. So with respect to everything we can take the graph. So now 10 rounds was there, let us take now 20 rounds. Generate the network, propose routing with neural network. So whenever it classifies as noise or very high noise, under that situation it will try to allocate more bandwidth to the node. Okay, whenever the energy of the node is entirely down, it is going to find out a new energy. So with every data transmission, the neural network is going to classify the noise status in the current network and will keep on allocating the bandwidth based on that. You see, the data is getting transmitted through the same path. There is no handoff because the node is having enough energy. So more bandwidth is allocated because there is high neural network is classifying that the noise is very high. More bandwidth would be allocated. Yeah.
यहाँ से यहाँ और यहाँ से ये शॉर्टेस्ट पाथ था।
ये शॉर्टेस्ट पाथ के हिसाब से तो डेटा ट्रांसमिशन नहीं होगा, ये 3G बेस स्टेशन है, तो इसके नज़दीक 3G बेस स्टेशन है, दिस इज ट्रांसमिटिंग टू इट्स नियरेस्ट 3G बेस स्टेशन, दिस एंड दिस अ 3G बेस स्टेशन. ओके, जब आप टावर की बात करते हो तो टावर में शॉर्टेस्ट पाथ, हाँ, it's a LTE system, it's not a mobile node. Now you can see that a node has lost its energy, so immediately the path has got changed. This is not shortest path algorithm. So whenever a node is adopting 3G, it is going to transmit from one 3G tower to another 3G tower. Okay, now as you can see that as the number of round is increasing, average energy consumption is also decreasing. BER, okay, is reducing, average delay is increasing. So let's again change the number of rounds to say 30. Okay, let's generate the network. And so neural network doesn't have to be trained every time. Okay, the neural network could be trained what do you call, once in, after some 3 to 4 simulation you can train neural network once, like that.
सर बेस स्टेशन एक ही रहता ना, चाहे वाईफाई का हो या फिर 4G का हो?
नहीं, देयर विल बी मेनी नंबर ऑफ बेस स्टेशंस. टावर काफ़ी सारे, तिमापुर चौक में एक टावर होंगे, जगत सर्कल में एक टावर होंगे, टावर फिक्स रहेगा.
उसी टावर से हम दोनों को एक्सेस कर सकते हैं?
दोनों को एक्सेस कर सकते हो. मतलब वी कॉल देम ENB नोड्स, ये जो ट्रायंगुलर मार्क है वी कॉल देम. So this is the bit error rate, average energy consumption is this much. Okay, now this is the proposed system. Now the same thing we can generate the network. Now we shall take only 10 number of nodes. Okay, let's simulate the present system. So once we simulate the present system, you can see there is no base station. Okay, you don't see any base station, so it is always going to try to find a path through which the data is going to be transmitted. Okay, even if some nodes energy is down. Okay, and when you run it, you'll see that there is no classification. I shall close it and show you once. Okay, just a second. This is this is the sync. The sync in the sense the internet node, or where all the data is being dissipated. Just to distinguish between the proposed system and the present system, I have displayed it with a different name. Sync is the destination node. Okay. average energy left is this one. Now you'll see that one more point in the graph has appeared. Now what we are going to do is,
सर यहाँ पे तो कोई ट्रांसमिशन हुआ ही नहीं.
it will be through the red color mark. It will not show you black color. In the proposed system, it will show you through black color. Here it will show the route itself, okay, because there is no shifting, right? In the present system, there is no shifting. Once the route is formed, okay, data transmission you can see from here, because here there is no handoff, okay, it's a plain DSR. Let us now take number of rounds to set 20, okay. Let's generate the network once more. Once you generate the network, again do just a second, 32 4 9 11. So what we are going to do is, let's close this, let's run it once more. This were the nodes. SNR we had taken as 20, number of nodes is 30, internet node is number 1, total number of rounds we want to take 20. Generate network and simulate present system. So this is your present system. You can see there is no classification, no routing change, no handoff, okay. Once the path is established, data is going to be transmitted always through this path, and this is always going to be the shortest path, okay.